target. I'm gonna come around and look at them, okay? Your final thoughts? Okay. Timer is up. So, move on. So I should compare and contrast chemical properties and changes and physical properties and changes. So who can tell? So right now it's a physical change. Physical properties, what are they? Color, shape, taste, density, and shapes and phases, right? Yeah, size, shapes, right? So color of something, when something changes color, and it's a physical property. So, like the bottle water. The water is what? Color change, right? It's still water on the bottom, right?
Yeah.
So it's a physical property, right? And also density, because which one is more dense? Is it the water or the oil?
The oil.
Is the oil more dense or less dense?
Less dense.
Good, because the water is lighter than the water. And then our last experiment we did the other day when we mixed in the salt and water. Remember? We separated. So is it a physical change or a chemical change? Why is it a chemical change?
Because of the
It shows a chemical change? Chemical change is physical change, right? Because we can do what? We can go back to a normal state. What did I do?
added color.
I color food coloring in it,
Salt.
and I added salt and water.
Both of them.
And
then
I,
you let it sit over time and it starts to, spread apart.
to create substance, right? So Hannah said that I mixed in water and salt and food color and let it dissolve to form what kind? What did it form? What did the water and food color and salt form?
And the solution.
A solution, right? And then I did what to it? I put it on a hot plate, right? I boiled it, and I boiled all the water off. The water went to a what? From a liquid to a what? To a gas. And it left me the salt that dissolved in it. So it's a physical change. What kind of mixture is this? What kind of mixture is this? Heterogeneous mixture. Because it's separated. Good. It's good, Joe. Proud of you all. So, when we think about physical properties, you think about color, the shape, taste, density, and the state, or the phase. How many states or phases are there? What is the state or phase of matter? That's four, yes. And how many, name them for me. Name one of them.
Plasma.
Plasma, good job.
Sodium.
Liquid.
Solid.
Solid, good job. Liquid, is that one?
Gas.
And gas. So liquid, solid, gas, and plasma are the four states of matter. And they're all of physical properties or physical changes. So physical change is color, taste, smell, and texture. You have this in your notes. Let's kind of review. Density is what? Equals mass over volume. You know that, right?
And it's the amount of substance that is in the same place.
That's what volume is. The mass is what? Mass means what? Taylor Diaz, what does mass mean? Huh?
Get to the stage.
Yeah? Or how what? Something feels. I weigh 175 pounds.
Dang.
That's my what?
Wait.
My weight. So my mass is
Wait,
175.
the mass is how you,
How much you weigh.
yeah.
So how much something weighs. Okay? Chemical properties. What happened? I do. Chemical properties are what? When something can't go back to its original state. You have a substance that changes, you mix something, has a reaction, and it changes a whole another compound or substance. It's a what? Chemical change.
Yeah.
So you have a reactant and a product. The product is what happens after the reactant. So it's a chemical change. So when you burn, say I'm gonna burn some wood for a fire. I put the wood into the fireplace and it burns. Is it a chemical reaction or a physical reaction?
Chemical.
Chemical, because can I take the wood, the ashes from the wood and turn it back to wood?
No.
No. Good job.
If it was physical, then you can change it back to wood.
I can reverse it back. So think about this. If I take some paper and I cut it up and tear it up, is that a physical change or a chemical change?
The chemical.
It's physical, because I can take the paper and melt it back down like they do in the factory and make it more paper or recycle it. That's where I recycle them. You have this chart in your notes. So no change of matter, shape, size, color, state. So let's go to the experiment. So you know when we have a chemical change, you're always gonna have a reactant and a product. Okay? You hear me? The reactant is the atoms you had before, the chemicals, the elements you have. You have the product. The product is what you get after the reactant. After the reaction takes place, what you get left over. Atoms cannot be destroyed. So matter cannot be destroyed, right? So what you have here is going to be here, but in a whole different substance or different arrangement. That's how you have chemical reactions. They're the same. I mix something and it reacts. It's still the same atoms because atoms can't be destroyed. Matter can't be destroyed. It has to go somewhere. Okay? So we have methane or methanol. And what's it on here? What's O2?
Oxygen?
Oxygen. Sorry, my handwriting. You know that already. So it says two molecules of oxygen, right? So you have two of those molecules. You know why? Oxygen does not want to be by itself. Why?
Because of the gas?
No, it's a gas, but why don't it be by itself? Anybody know? You know, Diana? Think about the valence electrons. Oxygen is missing two electrons to be full. So it needs two molecules of oxygen. Okay? So let's do this. And I can actually show you right here. So we have what? C. This demonstration for y'all to see how it will look. That's your methane. You have two molecules of oxygen. Okay? This is your reactant. Okay? I'm going to take this bottle. I'm going to pour in alcohol. I'm going to try this at home, okay?
I'm gonna try it.
Okay.
Make it nice. You're right. This one is short.
So it's not the fire wall.
Don't try it at home.
Is that cool?
Hmm?
Why don't you see?
Want to alcohol? It's in there. Still don't try this at home.
I'm gonna light it on fire.
Wait, I don't see nothing.
Because I did that at home. There's a fire right there.
It's invisible?
No, you can see it right there.
It's on there. It's just the alcohol.
So what's the point of this? Like, it's supposed to be invisible?
It's
trying to turn
Pay attention. Don't guess what it is. If you guess it, you can ruin it.
Don't guess, maybe guessing it wrong.
Exactly.
Just wait till I finish, all right?
Thank you for allowing me. Thank you.
Some better on the bottom. Which one better on the bottom?
Realize water's on the alcohol.
I'm trying to do it right now.
Mm-hmm.
Huh?
You're trying to get in. You're trying to make it.
Making alcohol invisible?
That's what you're trying to do?
It's clear.
You're cleaning the bottle.
I'm cleaning the bottom. Come along.
You done now?
Am I done now?
What?
I mean, done.
I don't get that. You just let everything go from there. You say, basically you're doing magic.
So if I had ethanol, if I use ethanol, this is like combustion. It's combustion, you'll see in a second what's gonna happen.
So light up.
Can you blow it up?
Which one?
I have a picture of one of them.
Oh! Oh, God! Oh!
This is. Got me? Alright.
Oh, crap.
This is how your motor in your car works. It's combustion. What happened? I put my hands over this.
It like,
It
builds up the gas because you were holding up the
The
gas.
air pressure.
Oh,
Listen up. Listen up. The air pressure inside was lesser than the air pressure outside. The air was pushing from the outside, pushing in on the bottom. And the funny, okay,
Why is it not burning?
and so here we go. This is our reactant. This is our product. This means yield. Write this down. This is our product. What's left over in your reaction? We have CO. Hold up. Listen up. Listen up. So after the reaction, you have left. After your reaction, you're gonna have this left. CO2
Yeah, H2O.
and H2O.
So water.
That's 1 2.
Just take.
CO2, H2O. What's CO2? Carbon
Carbon dioxide.
dioxide and 2 molecules of water. And look, I have left over.
What is that? Gas?
My water.
It's what?
My water left
It's
over.
water. You sure it's water?
No,
Water.
it's water.
But it's
Water.
not brown?
Carbon dioxide is gone.
Oh, so that's how we make
This is
water.
water.
Let's
No,
make
we just have.
It's brown because of the water.
Oh, so when you run out of water at your house, you just do that.
No.
That's
Don't
what
do
it's like.
that. Don't do that.
But listen up, you got me? So we have leftover I took the oxygen. We have what CH4, which is methanol, methane, methanol, plus oxygen, and it reacts together. It leaves you what? Carbon dioxide with water. So think about your car. When you put gas in your car, it's alcohol, right? Gas. It's actually ethanol. Plus oxygen. When the pistons are moving, it's putting in oxygen so that what? The car can move. And then when car's motor's running, and the gas, it leaves what? Carbon dioxide, which goes in from the gas, exhaust, and goes into the air, and water, which pours out of your exhaust pipe. And then sometimes it gets wet sometimes on the ground when you're driving. It's the water. This is the reaction. This is a what? Balanced equation. Think about this. When you have an equation, since these atoms are not destroyed, everything's over here, it's still over here. So let's look at it. You have, I'm gonna move these, okay? We're gonna be going into balancing equations on Monday. So you have, what, 1 carbon, 4 hydrogens, and what? 4 plus 4 for oxygen, because you have 2 right here and 2, what?
Oh, yeah.
It's 4, right? And then right here you have what? 1 carbon,
1 carbon, 2 oxygen,
4 hydrogens,
4 hydrogens,
and
4 oxygens.
4 oxygens. It's still the same. It's the same. The atoms matter is not destroyed. It just transforms to another substance.
Wouldn't it be 2 oxygens again over there because like?
No.
But the 2 doesn't that only count for the hydrogen?
No. See, 2 goes to both. It's in the front.
No, I mean the other 2, like the.
No, there's just 2 right here for oxygen.
Not that.
The
I'm saying,
2 behind the H.
yeah, behind
No,
the
that's
H.
for
That's-
Won't
this
that
is-
only go? Won't that only go to hydrogen? Because so it won't be 4, right?
Think about you multiply.
But you have 2 over there
And
with the
multiply
carbon.
this 2
And then you
Yeah,
have 2
that's what I'm
after.
saying, but like, isn't that 2 only gonna go to this one? Because there's only one
Yeah,
oxygen.
but this 2
over
goes
there.
to oxygen.
Yeah, but that wouldn't equal 4, that would equal 2.
Yeah, but over there it has
It's
2
right here.
oxygen.
2 plus 2.
You need to add it to
This hurts.
Yeah.
So we're gonna add this together.
Yeah,
the
yes,
other
yeah.
one plus
This
sign.
is yeah.
Okay.
Same thing's right here. You got it? Do everybody understand that?
Yeah.
Do everybody understand it?
You understand it, Leah?
Do everybody understand it? Say yes or no.
Yes.
I can go back over it again. Got it? Michael, can you take my bottle? And so since there's no oxygen in this bottle anymore, I have to put water back in to get what? Oxygen back in. So I can't do this reaction anymore with this right here. I gotta put more oxygen into the bottle. Or I gotta let it sit for a while for oxygen going into the bottle.
She's a cool singer.
So what you're gonna do now? What we're gonna do now is take your notebook and I want you to write about what happened in this experiment. Write your description words and Michael, Brendan. Listen to me first. You have to discuss that. Discuss with your partner. Take your notebook. Remember what happened in the experiment. Also write about chemical reactions. Explain to me the chemical reaction that you saw.
What is that, rubbing alcohol?
Yes, you write about alcohol, methanol. That's methanol. You can use rubbing alcohol. You can use ethanol. You can use isopropyl
What
alcohol.
is that right there?
That's what it is. We're going to get into balancing equations, chemical reactions on Monday. And you'll learn about combustion on next week. Good.
That's the one.
She's bringing $20 worth of dues. I give you a name already. So bring $20, it's in court, everything, and I'll give you a share of Christmas supplies. Get you set. For this to be a nice way. I want to give you 5 more minutes to start that, right there, and we're going to go to the restroom. Okay?
Why are you smiling? I'm finished.
You finished?
Yes, I said as soon as you
Oh.
get a water file and you water just, oh, that's the,
That's right at the beginning.
oh,
That's the beginning, but you want to know what this is. We do know the equal sign means like, the arrow sign means like equal. And this is equals to this after a reactor. Okay? What did I do? I apply what to it?
Pressure.
Heat. So if you put right here, you can put heat. And we know that we apply heat, it does what? Speeds up, right? Through the process, it speeds up the process. So heat, methane plus oxygen plus heat causes what? Carbon dioxide and water. So when your car is heating up, when the motor is heating up, you get this much faster. That's why this car warm up. When you drive your car, let it warm up, so the heat, and this happens.
it's like, it's, when we use the experiment, you know how you put your hand on the bottle thingy?
That's pressure.
Yeah, and then you know how you hold your breath and then you let go? It's kind of like that because it just, as soon as you let go of that gas, it just like made that noise.
So you said when you, it's compared to holding your breath. When you hold your breath, the lungs are what?
Filled with air. Filled with something.
Yeah, you release, let it go, right?
Yeah.
You can compare that. That's a good analogy. You can keep that in thinking about combustion
Like
anyway.
after it explodes, you put your hand on it.
After it, you reacted,
Yeah.
exploded, which is fine.
Do
After
you
it,
have to do that?
you don't have to, but I'm gonna handle it to show you all the air pressure.
That was scary.
But after that whole thing happened, you put your hand on it and then it'll consume and then it'll go.
Yes, because the air pressure in the outside was greater than the air pressure inside,
Like how much did
The
it?
reason it smelled bad is because it was burning the lung.
and carbon dioxide.
I did this long because it's something, you have an item for you. Like,
There wasn't.
Think about carbon dioxide. Think about carbon dioxide. When you have carbon dioxide in the air, what does it do?
Huh?
It's too much carbon dioxide is what?
Bad.
Bad. It destroys ozone, right?
Oh
But-
yeah, it like ruins our ozone layer and that causes all of the water.
But why? Because we have, that's what?